Hello everyone, this time we'll be looking at a question that has to do with specific heat capacity. Like we already stated in our first video here, we'll be talking about how to calculate the specific heat capacity. This is more like the mixture method. In this uh, in this question now, we were given a heated copper at a certain temperature of um, 120 degrees Celsius, and the mass of this copper is what 0.4 kilogram. And then after heating it, it was transferred to a calorimeter, which is about 0.01 kilo kilometer kilogram. I said kilometer, containing 0.1 kilogram of liquid of unknown specific heat capacity. At what temperature? The initial temperature of this substance is what of the mixture, that is calorimeter, and the liquid inside the calorimeter is what 30 degrees Celsius. Now I said that if the final temperature of the mixture is 50 degrees Celsius, calculate the specific heat capacity of this liquid. We are going to calculate the specific capacity. The specific heat capacity of copper is already given to us. So we know that heat loss by copper is equal to heat gained by what? The liquid by the what? Liquid, and also the calorimeter. The heat lost by this one is what these other ones are gaining. So in that case, the first thing we're going to do here is to calculate the heat lost by the quantity of heat lost by what? By the copper. To do this now, remember we have our formula. The quantity of heat is always mass C and temperature change. So in that case, for this our copper now, quantity of heat lost there is what? The mass of copper. The mass of copper is said to be what? 0.4 times specific heat capacity of copper, which is, and then temperature, change in temperature, which is the initially it was. So what we have here is initially it was at this temperature, then doing all of them were mixed together. You notice that all of them arrive at this temperature. So the heat lost by this is just by subtracting that from it. So when we do that, will be equal to that's what we have. When we subtract it from that multiply, we have a 10,920 joule of energy. So for the other side of it, we have the liquid, the heat gained by the liquid, the heat gained by the liquid, heat gained by the liquid will then be heat gained by liquid. We have the mass of the liquid is what? The mass of the liquid is times specific heat capacity, which is unknown, and then the temperature. The temperature in this case will then be, because the final temperature is this, and then minus this, we get our this will give us a heat change in heat. So when we subtract this, what we have here will then give us 2C. C stands for the specific heat capacity. Is that okay? Now we'll talk about the heat gained by the calorimeter. I wish I won't clean this thing. Heat gained by the calorimeter calorimeter, we have, and the mass of a calorimeter, the mass is what? Mass is, what do I have? Okay, 0.0901 times specific heat capacity of the calorimeter, since it's copper, and then change in temperature will then be 50 minus this. That will give us also 778 joule. That is what we have in that case, 78 joules. So we have all the things we need. Now remember, we said that the heat lost by this copper, heat lost by the copper is what the sum of the heat these other ones are getting, the liquid and the calorimeter, since they are all together there. So we're going to talk about the total heat. If we add up the heat together, the total heat gain, total heat gain will be 7 8 plus what 2c. That's for it. Now then, this is the heat gain, which is equal to the heat lost by the copper. We have our 7 plus 2c equal to our heat gain lost here by the copper block. We have so what we do here is that we subtract 7 8 from both sides. We will have, that will give us 42. So the next one is to get our specific heat, which is C. Now we have, the heat capacity of the substance is what? The specific heat capacity, joule per kilogram per Kelvin. That's the final answer. Thank you so much for watching.